Hey everybody, let's go ahead and take some notes on section 2 together. This is on verifying trig identities. Get my pen going. There we go. Okay, so we're talking about verifying trig identities, and this is slightly different than just simplifying, okay? The key to verifying trig identities and solving equations is the ability to use trig identities and algebraic rules so that we can rewrite trig expressions. An identity is an equation that is true for all real numbers in the domain. Okay, so it always works. So the list of guidelines for verifying is really similar to our same 4 methods that we were using today when we were talking about simplifying. Is we're still going to look for reciprocal identities. We're still going to put things in terms of sine or cosine as a strategy. We can still use alternate identities, right? Rearranging different identities. And we can also use algebraic operations like addition, subtraction, division, multiplication, and factoring. We could also use FOILing. And then the last thing that's a little bit different is when we're verifying, this only is necessary when we're verifying, we use one side only. So basically, you're going to leave alone the more simple side. Okay, so let's describe a strategy for verifying an identity that's sine theta tangent theta plus cosine theta equals secant. So you're going to look for which side is simpler, and we're going to leave this side alone. So we're going to be working the left side of the function, and we're going to be leaving secant theta alone, which basically means I'm going to be looking for this side to change. We're going to verify all the way down until it looks like secant theta, and that's when we're done. Okay, so the first thing I'm going to do is look at what I have and how do they relate each other. I notice that none of these are Pythagorean, nothing squared. I also see that sine, tangent, and cosine are they're not inverses of or not inverses, I should say, reciprocals of each other. So I'm going to put everything in terms of sine and cosine, okay? So if this is sine, it's already in sine. Tangent, I'm going to rewrite as sine over cosine. And then cosine again is already in terms of sine and cosine. Let's multiply what we have. Remember, we've got our numerator here is sine times sine. Well, that's sine squared. And our denominator is cosine times 1, so that's just cosine. And then we're adding cosine. Well, right now, if I wanted to add things, I don't have a common denominator. So I'm going to use some algebra to get a common denominator. And I'm going to multiply the right side of the equation by cosine. So I end up with sine squared theta plus cosine squared theta all over cosine because that's a common denominator. Well, what do I know about sine squared plus cosine squared? I know that, I'm going to put it right here, is 1. 1 over cosine. Well, 1 over cosine is just secant. And look, now they verify. Check. Just like on Instagram, right? Verified. Describe a strategy for verifying the identity of all of this. So again, you're going to look at your simpler side and leave it alone. For me, that's the right side here. You could choose either side, but it's going to be, you're going to have more to work with if you choose the more complicated side and simplify it. Okay, so for this, I don't see a lot going on as far as, like, this is a squared. This is a reciprocal function, but it's got a -1 attached to it. And then this is the same reciprocal function with a +1 attached to it. This is a clue. If I FOIL this out, this is going to be a difference of 2 squares. So what I'm going to do is I'm going to use FOIL to do these two. Okay, so I get cosecant times cosecant is cosecant squared. Cosecant times +1 is cosecant. -1 times cosecant is negative cosecant, which cancels it out. And then we've got -1. So that's what's inside. Outside of the parentheses, we're going to bring down our sine squared. And we're going to leave this here so that we can get it to verify. Now what I'm looking at, I got a sine squared, but look at this. I've got this 1 and cosecant squared. I know that we've got our Pythagorean theorem, sine squared plus cosine squared equals 1. I know if I want to get cosecant, secant is, let's see, if I divide everything by sine, if I divide everything by sine squared, okay, and this is if you don't have your notes in front of you, which you do, this will be easier. You're going to get 1 plus cotangent squared equals cosecant squared. So I can see here, look, I've got a 1 and a cosecant. So I'm going to minus that 1 over, and I get cotangent squared equals cosecant squared minus 1. So this, I see, is right here, so I'm going to replace it with cotangent squared. So remember, again, I'm still looking to get everything the same to 1 minus sine squared. I'm getting closer. I see sine squared times cotangent squared. So I don't have reciprocals of each other, so I'm going to put them in terms of sine and cosine. So sine squared is already in terms of sine, but cotangent is cosine squared x over sine squared x. What do you think is going to happen with sine squared divided by sine squared if this is a 1? Look, I can cancel these, so I end up with cosine squared x. Well, remember, we're still trying to match it up to 1 minus sine squared. Well, remember, this is my original Pythagorean identity, which tells me if I wanted to subtract the sine squared over, so if I've got sine squared plus cosine squared equals 1, if I subtract the sine squared, I get cosine squared equals 1 minus sine squared. And look, there it is. Equals right there. Check, verified. Lastly, we're going to verify this identity where we're going to pick our simpler side, and that's what's going to stay. And then we're going to look at everything out here that we need to simplify. We're going to look at what we have and how they're related to each other. I notice that I not only have squareds, I've got powards. Okay, I notice that both of this is cotangent cubed and cotangent cubed. So I'm going to start off, and I'm going to use algebra to factor. What that's going to leave me is, I see that both of them have a cotangent cubed alpha in common, and that leaves me cosecant squared minus 1. This looks a lot like a Pythagorean identity that we've seen before. Haven't we seen this? We already found it up here. Cosecant squared minus 1 is really cotangent. So I'm going to replace cotangent squared alpha right here. So what's cotangent cubed times cotangent squared? Well, that's cotangent to the 5th power, which is what we were looking for. And that is now verified. Okay, you guys, we're going to do some more of this tomorrow in class. See you.